Hello friends, today we are going to start the chapter 8 of class 9, which is motion. In the last 6 videos all I have done about class 10. Now I am starting my new classes on class 9. So pay attention guys, this is useful and will help you get your marks and good knowledge about the chapter and science more than you know. So starting the chapter, and guys do subscribe and do appreciate the video by pressing the like button. So let's start the chapter now. Starting from the first point, what is motion? Motion can be described in two parts. One is a body is in rest or a body is in motion. So what is rest? A body is said to be in rest or in a state of rest when its position doesn't change with respect to a reference point. So for example, let us take this is a point, and then this is a point. So let us take this as a traffic point and take this as a body. So when the distance between these 2 points doesn't change, this means the stationary one, which is the traffic point, and the movable one, which is the person or a body, doesn't change its position. That does means its distance doesn't get changed. So for rest we can write that a body is said to be in a state of rest when its position does not change with respect to a reference point. Now the next point, which is motion. So what does motion says? A body is said to be in motion when its position changes with respect to a reference point. So let us take this traffic point again and take this the body which was stationary with the traffic point, and let us suppose after some time this body changes its position from here to here. Now what does this means? This body has changed its position, so the distance also gets changed. So now we can say that the body had motion. So in motion we can write a body is said to be in motion when its position changes with respect to a reference point. So now there are three types of motion. The first one is linear motion. The second one is circulatory motion, and the third one is oscillatory motion. In linear motion, the motion we will study the motion in a straight line. In circulatory motion we will study the motion in a circular path, and in oscillatory motion the body will vibrate in both the sides. And this oscillatory motion has a big example, which is pendulum, which is already available, and you all know about the pendulum and its oscillatory motion. So we are going to study only the linear motion in class 9. These two are for the next classes. So let's start the chapter. From we have only have to study this single point, which is linear motion, and which is also a vast topic. So after studying the concept of rest and motion, now we are moving on to physical quantities. Now, what are mainly physical quantities? It is a property. It is a physical property of material that can be measured. Like in your body, you can measure many things like your height, your weight. So anything that could be measured physically is called physical property, and those physical properties are known as physical quantities. So what is physical quantity? It is a physical property of material that can be measured. So it is a physical property of material that can be measured. Now it also has two types. There are two types of physical properties. First one, which is scalar quantity. Now what is scalar quantity? It is a physical quantity having only magnitude, not direction. So it is a physical quantity having only magnitude, not direction. It does means it's that it doesn't have direction, only have magnitude. So what is magnitude? Your weight can be magnitude, like you are 30 kilo of weight, so this is the magnitude. If we add direction to it, then we can add like you are 30 kilo upward, you are 30 kilo downward, like that. You can be so another magnitude could be your height, like you are 6 feet tall. So these things are magnitude. And for example, if we add example for the scalar quantity, we can add speed, distance. So anything that doesn't have direction is called scalar quantity. So what's the next quantity? The next quantity is vector quantity. So now what is vector quantity? It is a physical quantity having both magnitude as well as direction. So these are those physical quantity having both magnitude and direction. Like what is magnitude? Distance. What is the distance? Let's say 45 kilometer. So this is the distance, okay? And this can also say this is the magnitude. So we have to add direction in it. So direction can be east, like in this example could be said as 45 kilometer east. So again another magnitude could be 40 kilometer west. So these are the things that vector quantity gives us the freedom of having both magnitude and direction in the same quantity. An example of these things could be velocity, acceleration, displacement, momentum, and force, and many other things. So this is the two physical quantities that we have to know to study this chapter further. One is scalar quantity, another is vector quantity. In scalar quantity we have to know about the magnitude, and in vector quantity there should be both magnitude and direction. Now the next topic which comes is distance. Now what is distance? The actual path or length traveled by an object is called distance. So we can write as the actual path length traveled by an object is called distance. Like a body is stationary here and you move to this position, there can be a distance of like 1 meter. So this is the distance traveled. So the actual path length traveled by an object is called distance. This is the distance, and which is 1 meter. So points to be noted is that it is a scalar quantity. Why it is a scalar quantity? Because it doesn't have direction. We are only talking about the distance of point here to here. It doesn't have any direction. The second point, which is it is always positive. It is always positive and can't be zero, which means the distance is always the distance between these 2 points can't be zero. What now the next is its SI unit is meter. Here as we can see, the SI unit is meter and we denote it by small m. So there are also many units in which we can calculate the distance. Those can be kilometer, millimeter, centimeter, etc. But here the SI unit is meter. So now let's take a graph here. 1, 2, 3, 4, 5, 6, 8, 9, 10. Let's say this is a point which is 0, then 8, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So if we take an object which is travel, let us take this point as A, which is travel to the point B, which is at 100. So what is the distance traveled now? It is 100. Now let us take this point as C and this point as D. If some problem says that the point A, the body from point A moves to point B and also travels up to point C. That does means it travels 100 meter and again comes to point C, which means 10, 20, 30 means it also travels 30 meter more. So the total distance will be 130 meters. So this is the way we calculate the distance of any body moving from a point to another. Now the next point, which is displacement. So what is displacement? The shortest distance between initial position and final position is called displacement. So what does this mean? The shortest distance between initial position and final position. It doesn't matter how much distance any body covers, it will only measure how much distance or in which direction the body covers the distance. It only measures the distance straight from the initial position to the final position. So what is initial position? The initial position is the position from which a body starts moving, and what is the final position? The final position is the position in which the body stops its movement. So now the points are, it is a vector quantity, which means here we should have both magnitude and also direction. The next point, which is it can have positive, negative, and can also be zero. The distance or the displacement, as we can say, which can be in positive or negative, and either also can be in zero, and its SI unit is also meter, which is small m. So now let's draw a straight line. 1, 2, 3, 4, 5. So let's take this as 0, 10, 20, 30, 40, 50, 60, 70. Okay, so this is the point A, this is point B, this is point C, and this is point D. So let's take, how can it be positive? So let us say a body travels from point A to B and B to C. So the body starts its initial position from here, and the final position will be this. So as we said, the body starts from point A, goes to point B, and again comes to point C, which means this body goes 100 meters this way and takes a U-turn to point C, comes this way. So what is the total distance traveled? 100 plus 10, 20, 30, 40. 140 meter is the distance traveled. So now what is the displacement? The displacement is from initial position to the final position, which is 60 meter. So this is the positive value of displacement. So now how can it be 0? Let us say the body A travels from point A to B and B to again A. So the body travels from starts from here, goes to point B, takes a U-turn, comes back to point A, which means the initial position and the final position are the same. So this is the point where both the this is the point where both the points come and submerge in itself, so the displacement will be 0. So let us take a body starts moving something in this manner, traveling, going to distances, and comes to this point. So it doesn't matter how much the body has traveled, it only matters what is the displacement of initial position to the final position. So this is the initial position to the final position. So let us take a body again which has traveled 100-meter distance to this way and again comes back 40 meters this way. So the displacement will be again 60 meter, which is in this way. This is the displacement, this is the initial point, this is the final point. So this is the displacement, which is 60 meter, and as we know, we have to add direction in it because it is a vector quantity. So let us take this side as east, because this is west, this is north, and this is south. So always remember guys, east, west, north, south are not only the direction. It can be upward, downward, forward, backward. So there can be many types of directions. So you need to recognize all this when you will solve the problems. Now you find out the difference between distance and displacement and tell me about the differences in my comment section. So the next point will be speed, and also we will study here of velocity, which will make these points easier to remember. So now what is speed? The distance traveled by a body per unit time. What is speed? The distance traveled by a body per unit time, which means when a body travels a distance, we have to find out its speed per unit time. So how can we find out speed? Speed will be equal to distance upon time. So this will be the formula by which we are going to find speed. So speed, it is a scalar quantity. Why? Because it doesn't talk about any direction. It will always be positive because distance is a positive value. So now SI unit, what will be its SI unit? So we can find out here the SI unit. As we know, the SI unit of distance is meter and the SI unit of time is second. So the SI unit will be meter per second. Got it? Now velocity, the distance traveled by a body per unit time in given direction. Here the direction has got added. In short, we can say that it is speed with direction. What is velocity? It is speed with direction. Now how can we find velocity? So as direction has got added, it will be displacement upon time. Okay, because displacement has both magnitude and direction. As it has got direction with it, so it is a vector quantity, and it will also have it can also have positive, negative, and 0. So how can it be positive when the displacement will be positive? How can it be negative when the displacement will be negative? And how can it be 0 when displacement will be 0? So now SI unit. So what can be the SI unit? As displacement also we know the SI unit is meter, and for time the SI unit is second. So it also comes as meter per second. This both speed and velocity has SI unit same, which is meter per second. So you can look for the differences between these two, as it has only the distance traveled by a body per unit time, and this will be about the distance traveled by a body per unit time in given direction. This is a scalar quantity, this is a vector quantity. It will be always positive, it cannot be positive, negative or 0, and this two both has same SI unit, which is meter per second. In speed we can find the value by distance upon time, and in velocity we will find it by displacement upon time. Now the next topic is average speed. What is average speed? Suppose a question is given in which two distances are given and two different times are given. So we have to find out the average speed. So how can we find the average speed? Average speed will be equal to total distance by total time. This will be the formula by which we will be finding average speed, which is total distance by total time. Now how can we find the average velocity? Suppose two velocities are given and we have to find the average velocity. We will be finding the average velocity like initial velocity plus final velocity. These two velocities will be getting divided by 2. This is the formula by which many problems will get solved, and this is the formula for average speed, and this is the formula for average velocity. The next point is types of motion. So now what are the types of motion? We have to know that there are two types of motion. They are uniform motion and non-uniform motion. So first of all, what is uniform motion? When a body travels equal distance, when a body travels equal distance in equal interval of time, then the motion is said to be uniform motion. So what is said here? When a body travels equal distance in equal interval of time, then the motion is said to be uniform motion. Which means, let us start this by looking at an example. Let us take this as a vehicle which is at its initial position, which is 0. Let us take equal interval of time. Let us take 1 hour, 2 hour, 3 hour. So let us take this vehicle travels 70 km in 1 hour, then 140 km in 2 hour, then 210 km in 3 hour. Which means in equal interval of time, which is 1 hour gap in each point, and travels equal distance in every hour, like 70 plus 70 140, 140 plus 70 210. So this is something which is traveling, or which is a car which is traveling equal distance in equal interval of time. Now what about the graph? Let us suppose this is the graph, this is the y-axis, this is the x-axis. So on this side we will be writing the time interval, and on this side we will be writing the distance interval. And always remember, the graph of uniform motion will be going in a straight line, because in equal interval of time this object will be traveling equal distance. Again, in equal interval of time this object will be traveling equal distance. So the graph will be always in a straight line. Now the next type is non-uniform motion. So now what is non-uniform motion? When a body travels unequal distance in equal interval of time, it is said to be non-uniform motion. What does this mean? It does mean a body travels unequal distance in equal time interval of time, which means in a non-uniform motion there is also equal interval of time, but the body travels unequal distance in every equal interval of time. Let us take the example again. Suppose this is the initial position 0, this is first hour, this is second hour, this is third hour. Suppose this is a car again. It travels 70 km on the first hour, then travels 90 km on the second hour, and again travels 140 km in third hour. What does this show us? This shows us this is the equal interval of time, but the distance traveled by the vehicle is not equal, because in the first hour it traveled up to 70 km, then it traveled only 20 km between this distance, which is plus 20, which becomes 90, and again from here to here it traveled 50 km, which means the distance traveled by the vehicle is unequal, but the time interval is equal. So what will be its graph? Let us take this as graph. This is x-axis, this is y-axis, this is the time interval, this is the distance travel. So in this graph there can be many forms, like the distance is raising and getting less, the distance can always get less, the distance also can get high. These are the three possibilities of the graph in non-uniform motion. Now the next topic is symbols. We have to know also about some symbols if we have to study the physics. So in this chapter we are going to study about some different values of different topics. So we have to know the symbols because we have to understand the question. Sometimes it will be given in those symbols, added some value in it. So let us start. So first of all is distance. Now what is distance? Distance stands by s. The next is displacement. Displacement stands by del s. You will see a triangle shape before the s, which means displacement. Then initial velocity. Initial velocity will be denoted by small u. Then final velocity. Final velocity will be denoted by small v. Then time. Time will be denoted by small t. Then acceleration. Acceleration will be denoted by small a. Then also remember speed will be same as velocity. So both their symbol will be v. So here the condition comes where we have to see about both the speed and velocity, which is distance upon time, which will be v is equal to what is distance? Distance stands by s, and what is the time? Time is denoted by t. So this is the formula for many problems we are going to solve further. So remember this is important. Now the next topic is acceleration. What is acceleration? The rate of change of velocity of an object with respect to time is called acceleration, which means the rate of change of velocity of an object with respect to time is called acceleration. So when a body changes its position from from initial position to final position with respect to time is known as acceleration. So we also have to know that it is a vector quantity because it both have direction and magnitude in it. So how can we find acceleration? So suppose u is initial position, v is final position, and the time traveled is t. So as we know, acceleration is denoted by a. So we will have to find initial position upon final position minus initial position upon t, which is the formula for acceleration. V is final position, small u is initial position, and upon t. This is the formula for finding acceleration. So some points are there. We have to know that it may be positive or negative. There are some conditions. I will tell you about those, when it will be positive and when it will be negative. So now negative acceleration is also retardation or deceleration. And now what is its SI unit? We can find out what is the SI unit of velocity, which is meter per second, and what is the SI unit of time, which is also second. So now the SI unit will be meter upon second square. So the SI unit is equal to meter per second square. So now how can we say that it is a positive acceleration or negative acceleration? So I will be showing you two categories to decide about positive acceleration and negative acceleration. So first of all, first condition is when initial velocity, which is u, is lower than final velocity. Now let's suppose initial velocity small u is 20 meter per second, final velocity small v is 50 meter per second, and time small t is 5 seconds. So what is the formula for acceleration? A is equal to v minus u upon t, which is equal to 50 minus 20 by 5, which will be equal to 30 by 5, which will come answer as 6 meter per second square. This is a positive value and this is known as positive acceleration. So now what is negative acceleration? So now for negative acceleration, when initial velocity is higher than final velocity. So in this case, the small u is 100 meter per second, small v is 60 meter per second, and time taken is 4 seconds. So putting up the formula again, acceleration is equal to v minus u by t, which is equal to 60 minus 100 upon 4, which is equal to minus 40 by 4, which is equal to minus 10 meter per second square. This is something called negative acceleration. So remember this, guys. This is positive acceleration, this is negative acceleration. This is a positive value and this is a negative value. So these two are described in these conditions. The next point is graphical representation of motion. So now what is the graphical representation of motion? The first one is distance time graph. So distance is denoted by s and time is denoted by t. So suppose this is a graph. This is s, which is distance travel. This is t, which is time travel. This is the initial position. So let us suppose this is a straight line which represents velocity. So this means this is a uniform speed velocity graph, which means this is the distance traveled per hour or per unit time is equal. So suppose we have to find out, suppose this is 2 points, these are 2 points, and we have to find out the distance from A to B. How will we find this thing? So we will draw a line straight to the x-axis and also a line straight to the y-axis. Okay, and this we will take as T1, this will as T2, this one we will take as S1, and this will be S2. So what was the previous formula for velocity, which is V is equal to S upon T. So how can we find out this distance? For finding this distance, we have to change the formula in such a way that we find the answer. So this is the distance. To find out the distance from S2 to S1 will be S2 minus S1 upon time. Time will be T2 minus T1. So this is the uniform speed velocity graph, and this is the formula to solve the distance time graph. So this was the uniform speed first one, and now we will see the second one, which is non-uniform speed. This will be the same graph, time S, but the graph will be different. It can be like this, it can be like this, it can also be like this. So the graph can be in different shapes and size, but the formula will be same. This is for the non-uniform speed or velocity graph. Okay, now the next graphical representation is velocity time graph. So let us make a graph. Suppose this is the time and this is the velocity, which is in meter per second, and let us suppose take this graph as uniform motion, in which motion is in uniform. Let us suppose a curve is going this way, which is A. This is a acceleration bar. Always remember that. Now suppose we are asked that this is A and this is B. Now what is the distance of A to B? So we will draw a straight line on the time line, and again draw a line on the same path. So let us name this as C and D. So this area, when we will find the area, we will get the distance of A to B. So this is the formula to find uniform motion from A to B in uniform motion velocity time graph. So now the second graph is for uniform acceleration motion. Again, this is the time, this is the velocity, which is in meter per second. Suppose this is the acceleration, which is in uniform form. So suppose this is A and this is B. We have to find the distance between A to B. So we will draw a straight line again on both the sides. So we have to find the distance. So if we find the area of this A, B, C, D, we will get the distance from A to B. These are the two graphical representations. One is distance time graph and another is velocity time graph. So now we are starting the most important topic, which is equation of motion, equations of motion by graphical method. So what are the equations of motion by graphical method? There are three equation of motion. Number one is equation of velocity time relation, number two is equation of position time relation, and number three is equation of position velocity relation. So you have to remember these three equations because this is the most important topic of the chapter. So the first equation is V is equal to U plus AT, which is number one, and also you have to remember the names of the equation, which is equation of velocity time relation. Then number two, which is S is equal to UT plus half AT square. This is the second equation and it is known as equation of position again time relation. Then number three, 2AS equal to V square minus U square, which is the third equation. This is the equation of position with velocity relation. Okay guys, you have to also remember the names of the equation because in exams it could be asked about write down the equation of velocity time relation. So you have to know the names of the equation and also the equations itself. So now we are going to describe these all three equations. So be concentrated. These are the important topics we have to cover. So starting with the first equation, which is equation of velocity with time relation. This is also known as first equation of motion. So here we have to draw a slope of velocity time graph. So let us say this is a graph. This is for time and this is for velocity. So here an acceleration curve is given, which is A to B. So now we have to find out the first equation of velocity. So how will we finding this? Let us suppose this AB curve is equal to acceleration. Then drawing lines straight from B to the timeline, then one from B to the velocity line, then one from velocity to the B line. So now let us name this. This is A, this is B, this is C, this is D, and this is E. So now we have to know that slope is equal to rise by run. This is the run, and also this is the run, AD is the run, and rise is BE. So the rise, the rise is BD, sorry, the rise is BD and the run is AD. Okay, so let's solve this. What is this? So looking at the equation, slope is equal to rise by run. Which is the slope? Slope is AB. What is the rise? The rise is B to D. This is the rise, BD by, now what is the run? AD. Okay, so now we have to know the value of BD. So how can we find the value of BD? Let us take this line, which is BC. Now BC is equal to BD plus CD. Okay, BD plus CD. Now we have to know the value of BD. So taking out, let's bring CD this side, which is BC minus CD is equal to BD. So this is the value of BD. So putting the value of BD, now here AB is equal to BC minus CD upon AD. Now look at BC. What is BC? This is BC. So looking at its the other line of the object, which is, sorry, this is 0. BC is equal to OE. Okay, and OE is the final velocity and OA is the initial velocity. This curve is starting from here, so this is the initial velocity, and the curve is ending here, so this is the final velocity. So we know that AB is acceleration, so putting the symbol of acceleration, which is A is equal to BC. BC is equal to OE. OE is the final velocity, which is V, and CD, this is CD, and OA are equal. So OA is the initial velocity, so putting the value of CD, which is U, and again what is AD? AD is equal to OC. Okay, AD is equal to OC, and OC is the time traveled by the curve, so we will put T here. Okay, so now let's bring T to this side. When this is in the denominator form, so it will multiply with A, which is AT is equal to V minus U. Okay, so also let us bring U to this side. Now this is negative, so this will become positive. AT plus U is equal to V. So if we alter this both sides, then we will get the first equation of velocity, which is V is equal to U plus AT. Okay guys, this is the first equation of velocity which we have got. So this is the mathematical method of bringing out the first equation, which is velocity time relation. So now the second equation, which is equation of position time relation, which is second equation of motion. So also you have to remember the first equation of velocity time relation, because that equation will be needed here to solve this problem. So we have to find out here, we have to find out the area under the AB curve, under the slope. So this is the area under the slope. We have to find out its area, which is we can also write area under slope is equal to displacement. You can call it displacement or distance, both are the same thing. So what is displacement? Displacement is equal to area of OABC, which is OABC. So we have to find out the area under the curve, which is AB. We have to find out this area. Okay, so we can also see here that this section is a rectangle section. Okay, this whole section is a rectangle section, and this section is a triangle section. So how can we find the area under the curve? We have to find out the area of this rectangle plus area of this triangle. This is easy, guys. So now the area of OABC is equal to area of rectangle, which is OADC or OACD. That is, we can write area of rectangle AOCD plus area of triangle. This is the symbol of triangle, which is ADB. Okay, this is ADB. So here we can write area of OABC, which is distance or displacement. That displacement symbol, the symbol of displacement is S. S is equal to, now what is the area of rectangle? How can we find the area of rectangle? Which is length into breadth. This OC is length and CD is breadth. So these lines are similar and equally parallel to each other. So we can write that OC multiplied by OA. This is the area of rectangle plus, now we have to write the area of triangle. Now what is the formula for area of triangle? Half into base into height. Now half into, what is the base? Base is AD. And what is the height? Height is BD multiplied by BD. Now we have to find out the how the value of BD. So if you look at this, BC is we can find out the BC by adding BD with plus CD. So we have to write BD plus CD. Okay, now we have to find BC. We have to find BD. So to find BD, we have to do a simple thing, that is BC minus CD is equal to BD. CD comes this side, it becomes in negative form. So this is the value of BD. So now here we have to put the value of BD. OC into OA plus half into AD plus BD. Now what is BD? BD is BC minus CD. Okay, sorry, this is multiplication into. So now what's next? The next is we have to solve the first equation, which is V is equal to U plus AT. Okay, before solving this we have to do one more line. So S equal to, what is OC? OC is the time, okay, which is T. Now what is OA? OA is the initial velocity, okay, that is U plus half. Now what is AD? AD is equal to OC, so AD is also time, that is T. Now we will put the value of BC minus CD. How? We have to find out this. Okay, what is BC? BC, this is BC, which is equal to OE. OE is the final velocity, which is V minus CD. What is CD? CD is equal to OA, which is initial velocity, which is u. Now solving this, we have to find out v minus u. So v, u comes this side, which is u is equal to 80. Okay, this is 80. What is the value of v minus u? Is equal to 80. Now putting the value of v minus u is s equal to, multiplying these two, it becomes ut plus half t. v minus u is 80. Okay, now we have to multiply this t into this t, which will become t square. A will stand as it is, so s is equal to ut plus half at square. So this is the equation, which is the second equation of motion, which is equation of position time relation. This is very simple, guys. We have to simply find out the distance between B to C, and you will get the equation easily. So we are going to start our third equation, which is number 3, equation of position velocity relation. Okay, which is also known as third equation of motion. So always remember, guys, you have to draw the same graph each and every time. Okay, so now here we have to find out also the same area under the curve, okay, which is AB. So to find so here we can see there are two parallel lines which makes it a trapezium, okay, which is OABC. Now it becomes a trapezium. We have to put in the value of trapezium, and we will get our third equation. Okay, so area under slope. So area under slope is equal to displacement, as I said earlier in the last equation, which is equal to area of OABC. So to find out OABC, we have to put the formula of trapezium, because two sides are equal. Two sides are parallel. So now here the area of trapezium, which is OABC, is equal to half into the addition of two parallel sides into altitude. What is altitude? The distance between two parallel lines. Okay, what is, now we can write half into addition of these two lines, which is BC plus OA, and we have to multiply it with altitude. Altitude is the distance between two parallel lines, which is OC. This is OC. So now here area of trapezium, which is displacement, OABC is the displacement, so displacement we can write as S. S is equal to half into, now what is BC? BC is equal to OV, which is the final velocity. So this will also can be told as the final velocity, which is BC. So BC is equal to V plus OA. What is OA? OA is the initial velocity, which is U, multiplied by OC. What is OC? OC is the time. So here we have to find out the value of T. So to find out the value of T, we have to put in the equation, the first equation, which is V is equal to U plus AT. If we keep the T this side, we will come with V minus U divided by A, because the A is multiplied by T. So it will come dividing in this side, which is equal to T. So now we will be putting the value of T here. So S is equal to half into v plus u multiplied by the value of t. What is the value of t? V minus u by a. Okay, we have come out like this. Now we will solve this and we will get our equation. So s is equal to, so now when we multiply this v plus u with 1, it gives us the same value, it stays same, which is v plus u. So we will write v plus u and multiply this again with 1, it also becomes v minus u. It stays the same way, and we bring the a and 2 here, which is 2a. Now we will take this 2a this side, which will become 2as is equal to v plus u, v minus u. So in mathematics you have studied that a plus b, a minus b is equal to a square minus b square. So here we can write that v plus u, v minus u is equal to v square minus u square. So here we come up with our third equation, which is 2as is equal to v square minus u square. And always remember, to solve these three equations you have to draw the same graph, and always you have to find out the displacement or the distance under the curve, which is OABC. Here you have to put in the formula of trapezium to find out OABC. So remember these three equations, guys. These are the most important topics in class 9. So we are here with the last topic of this chapter, which is distance or speed of a circular path. So here we have to find out the distance upon a circular path and the speed in circular path. So suppose this is a circle, let us take this as a center, this is the radius small r. So suppose a body travels, a body starts from here and travels the circle and ends up here. So how can we find out the distance in a circular path? So when the body travels on the outer line of a circle, we have to find out the circumference of the circle. So what is the formula for circumference of a circle? It is 2 pi r. And if in the question the value of pi is not given, then you have to take the value of pi as 22 by 7. So solving the formula, which is 2 pi r, you will get the value exact u1. Again, the speed, if we take the body travel is circumference in time t. So what is the formula for speed? Speed is equal to distance upon time. What is the formula for distance? Distance is 2 pi r by time, which is taken as t. So guys, here we come up with the end of this chapter. Hope you guys like the video, and obviously do subscribe, guys, because if you do the subscription, if you press the subscription button, you will be updated as soon as I upload the next video. So the next 2 videos are coming soon, which are the mid chapter questions and the exercise questions. So study hard, guys, the exams are coming, and I hope you all are staying safe at home. So thank you.